Hi students, welcome to today's class. In this class, I am going to explain very few important points, miscellaneous points I am going to explain. So, they are very useful for our preparation for competitive examinations. Okay. So, see this concept here. If alpha and beta are the eccentric angles of the extremities of a focal chord of an ellipse S is equal to 0, then cos of alpha minus beta by 2 is equal to E times cos of alpha plus beta by 2. Now, what is this concept is, take an ellipse, any ellipse. So, this is a x-axis and the y-axis. Take this is an ellipse. So, this is a ellipse. Okay, any ellipse, maybe that is horizontal or vertical or any type of ellipse. Alpha, beta are the eccentric angles of the extremities of the focal chord. So, you want to take a focal chord. A focal chord means is a chord passing through the focus is called a focal chord. So, this is equal to A and B. A and B are the extremities of the focal chord. Let the what you call that eccentric angle of A is alpha and the eccentric angle of B is beta. Already we explained what is eccentric angle. Okay, now then the relation between alpha, beta and E is, see here, cos of alpha minus beta by 2 is equal to E times cos of alpha plus beta by 2. That means E is equal to cos of alpha minus beta by 2 upon cos of alpha plus beta by 2. So, if you want to find out the eccentricity of the ellipse, that is given by cos of alpha minus beta by 2 upon cos of alpha plus beta by 2. Okay, now, where alpha and beta are the eccentric angles of the extremities of the focal chord. Okay, now. So, there is another relation is also there, that is tan of alpha by 2 into tan of beta by 2 is equal to E minus 1 by E plus 1. So, this is a very easy one. Why? Because from this only you will get this result. So, this is a by 1. So, E minus 1 by E plus 1. So, by taking componendo and dividendo, you will get this relation. So, the main relation is E is equal to cos of alpha minus beta by 2 upon cos of alpha plus beta by 2. Okay, now. So, very important result this is. I hope that you understand this result. So, let us go for next result. Welcome back. Second very important point is, if the chord joining the points alpha and beta, chord joining the points means, see here, alpha and beta, that means the points whose eccentric angles are alpha and beta. Okay, now, on the ellipse S is equal to 0, cuts the major axis at a distance d units from the center, then tan of alpha by 2 into tan of beta by 2 is equal to d minus a by d plus a. What it is, let us see this. Okay. So, there is an ellipse. So, let us take a horizontal line x-axis and it is y-axis, x-axis, y-axis, and it is horizontal line. So, this is equal to ellipse. Okay, now. So, this is an ellipse. Okay, so there is a chord joining the points. It is a chord. So, chord means what? So, let us take this is a chord. That means joining any 2 points. So, that is A and B. It is a chord joining 2 points A and B. The eccentric angle of A is alpha and the eccentric angle of B is beta. And it is given that this chord is cuts the major axis at a distance d units from the center. That means, so this is the center, this distance is equal to d. This distance, that is, it cuts the major axis at some P, the distance between C and P, center and this point of intersection is D. So, it is at a distance D units from the center. Then the relation between alpha, beta and D is, the relation between alpha, beta and D is tan of alpha by 2 into tan of beta by 2 is equal to D minus A by D plus A. So, and once again I am telling D minus A by D plus A. Understand this? At a distance of D minus A by D plus A. Okay na? So, what is A? So, ellipse equation is x square by A square plus y square by B square is equal to 1. From there, we will take this A value. Okay na? Right. I hope that you understand this concept. So, let us go for next concept. So, let us take one problem. So, basing on the problems concepts we discussed. So, here the problem is if the chord through the points whose eccentric angles are theta and phi on the ellipse x square by 25 plus y square by 9 is equal to 1 passes through the focus. So, passes through the focus means what? It is a focal chord. Then the value of tan of theta by 2 into tan of phi by 2 is. So, that is the question. So, he is saying one of the focus, we do not know which focus it is starts. So, let us take this in a short trick we can do is here it is a, so let us take this is an ellipse and it is a focus and it is a focal chord A and a B. If it passes through here, the previously I said it should passes through AE comma 0. Okay, now the focus is AE comma 0, another focus is minus AE comma 0. If the chord passes through the focus AE comma 0, if its eccentric angle is alpha and its eccentric angle is beta, we have the result tan alpha by 2 into tan beta by 2 is equal to E minus 1 by E plus 1. E minus 1 by E plus 1. That is the thing we have. So, here in place of alpha it is given theta, in place of beta it is given phi. Therefore, our result should be tan theta by 2 into tan phi by 2 is equal to E minus 1 by E plus 1. He is saying that one focus passes through one focus, let the focus be AE comma 0. Therefore, our result is A minus 1 by E minus 1 by E plus 1. So, if you find out E eccentricity, the problem is over. Now, what is the eccentricity of the ellipse? E is equal to, we know that root of A square minus B square by A square, that is equal to 25 minus 9 by 25, that is equal to 25 minus 9 16, 16 by 25, that is equal to 4 by 5. So, substitute E is equal to 4 by 5. So, here 4 by 5 minus 1 by 4 by 5 plus 1, this is a minus 1 by 9. 4 minus 5 minus 1 by 5, I cancel, minus 1 by 9. Therefore, minus 1 by 9 will be our answer. In this stage, you may get one doubt. Sir, how can you say that the chord, he is saying that one of the focus, if this chord passes through this focus, that is the minus AE comma 0, then what will be our answer? Okay, now. At that time, we have to follow this, first of all, we have to find out the focus of that, that is S is equal to, we will get minus A means 5, E means 4 by 5. So, that is equal to comma 0. So, that is minus 4 comma 0. Now, we know that equation of the chord x by A cos of alpha minus beta, that formula is there. There you have to substitute and again you have to substitute minus 4 comma 0, then you will get the answer minus 9. You will get the answer minus 9, but here we have minus 1 by 9. So, therefore, our answer is minus 1 by 9, therefore, minus 9 is not there. Okay. I hope that you understand this problem. So, let us see some more concepts. Welcome back. So, let us see one more problem here. Minimum area of the triangle by any tangent to the ellipse x square by A square plus y square by B square is equal to 1 with the coordinate axes. See here, let us see this ellipse as, so this is y axis and it is x axis. Consider an ellipse x square by a square. So, this is an ellipse. Okay. On the ellipse, there are infinite number of points are there. So, take any point as you like. So, if you draw a tangent like this, let it intersect the x-axis at A and the y-axis at B, then he is asking to find out, the minimum area of the triangle AOB. Let C be the center, ACB, minimum area. That means the triangle will be a variable triangle. Why? Because this depends upon that point where you have taken. So, if you take a different points, you will get a different triangles you will get. Automatically different areas you will get. Now, he is asked to find out the minimum area of the triangle formed by a tangent with the coordinate axis. Okay, now let us see the solution here. So, here it is given the equation of the ellipse is x square by y square, x square by a square plus y square by b square is equal to 1. Let P be any point whose eccentric angle is theta. Let P be any point whose eccentric angle is theta. Therefore, equation of the tangent at theta. Equation of the tangent at theta is given by x by a cos theta plus y by b sin theta is equal to 1. X by a cos theta plus y by b sin theta is equal to 1. Okay, now, so this is the equation of the tangent at theta. Let theta be any point on the ellipse. Now, this line intersects the x-axis at A. Therefore, what are the coordinates of A? So, A coordinates means y coordinate is 0. Okay, now, so wherever y is there, substitute substitute 0. Then what is your x value? So, what is your x value? This x value is given by A by cos theta. What are the coordinates of B? B is on y axis, therefore, x coordinate is 0. So, wherever x is there, substitute x. Then what are the coordinates of B? So, this is equal to B by sin theta. Okay, now, right. Yes, we know the x-intercept is equal to A by cos theta and y-intercept is equal to B by sin theta. What is area of the triangle ACB? That is equal to half modulus x-intercept into y-intercept. So, that is product of the x-intercept into y-intercept. That is half modulus. What is x-intercept? That is A by cos theta into. What is y-intercept? B by sin theta. So, this is equal to modulus of AB by, we can write it as a cos theta into sin theta. So, cos theta into sin theta, already 2 is there, 2 cos theta sin theta, sin 2 theta, okay, now. So, we got modulus of AB by sin 2 theta. What is its minimum value? What is its minimum value? He is asking the minimum area, So, you will get the minimum area that depends upon the theta, okay, now, sin 2 theta value. The minimum value of sin 2 theta is -1. From trigonometry, we know that the maximum value of sin theta is any real number. Maximum value is 1 and the minimum value is -1. So, let us take sin 2 theta as a -1. So, AB by -1 minus AB, modulus of AB is equal to AB. So, here its minimum value is -1. So, mod is equal to AB. So, therefore, the minimum area of the triangle ACB is A into B. The minimum area of the triangle ACB is A into B. Okay, now. So, what is your A? Semi major axis. What is B? Semi major axis. So, minimum area of the triangle is A into B. So, I hope that you understand this problem. So, let us go for one more problem. Welcome back to some more very important concepts. So, the first concept is equation of the chord of contact of x1 y1 to the ellipse s is equal to 0 is s1 is equal to 0. So here one word came, what is the equation of the chord of contact? What is chord of contact? First of all, we should know that what is chord of contact. Very easy. Let us take consider an ellipse. This is an ellipse. Let us consider any point. So the point may be outside and on the circle or inside. Let us take. So if you take a point, external point P, from P draw the tangents. So a maximum of two tangents we can draw. Let it touches the ellipse at A and B. Let the tangents drawn from P touches the ellipse at A and B. So let us join A and B. So this AB is called, chord of contact. Contact means this is joining the two contact points, that is called chord of contact. The line joining those 2 points is called chord of contact, right? So now if you want to find out that equation, the equation is given as S1 is equal to 0. Already we explained notation. What is S1 is equal to 0? So in place of x square, substitute xx1. In place of y square, substitute yy1. So in place of 2x, substitute x plus x1. In place of 2y, substitute y plus y1. Like that you will get S1 is equal to 0, right? If this point P is happens to be on the ellipse, if the point is happens to be on the ellipse, then what is there at a P? Then the tangent will acts as the chord of contact. When if point P is lies on the tangent, then AB will move towards P such that at a point P, the chord will become tangent. The chord will become tangent at that point P. Then also the equation of the chord of contact is S1 is equal to 0. The next case is if the point P lies inside the ellipse. If the point P lies inside the ellipse, then there is no question of chord of contact. Why? Because you cannot draw the tangents from a point P which lies interior of the ellipse. You cannot draw a tangent. So why? Because it lies interior of the tangent, you cannot draw the tangent. So in this case, there is no question of chord of contact. So if a point P lies either outside or on the ellipse, then only the equation of the chord of contact is S1 is equal to 0, right? So coming to the second point, the equation of the chord of the ellipse S is equal to 0 having x1 y1 as its midpoint is S1 is equal to S11. So this is also very easy concept. So let us take an ellipse. It is an ellipse, whatever may be that ellipse. Let us take any chord AB. Chord is AB. Let P x1 comma y1 be the midpoint. So P x1 comma y1 be the midpoint of that chord AB. Only the midpoint is given x1 comma y1. Then the equation of that chord is given as S1 is equal to S11. Okay, now you know that for notations S1 and S11. So very nice. The second one is reverse process. What is the reverse process? If the midpoint of the chord Lx plus My plus N is equal to 0 of the ellipse S is equal to 0 is this. That means if midpoint is given, then what is the equation of the chord? S1 is equal to S11. If the equation of the chord is given, that is Lx plus My plus N is equal to 0, then its midpoint is minus A square Ln by A square L square plus B square M square, comma, minus B square Mn by A square L square plus B square M square. Understand? So these two are, we can call it as a opposite, vice versa concepts. So if midpoint is given, then the equation is S1 is equal to S11. If the line equation is given, that the equation of the chord is given, that is Lx plus My plus N is equal to 0. Then its midpoint is the formula minus A square. So we know that A value, B value, L, M, N, all the values we will substitute here, we will get the midpoint. Okay, now. So I hope that you understand these 3 points. Coming to the fourth and fifth, they are very, very familiar. That is area of the ellipse is pi AB. So why? Because this ellipse is also a closed figure. So simple closed figure, definitely it will have a area. So finite area it will have. It is not an open curve. It will have a area. So for parabola you didn't have the formula. For parabola and hyperbola you didn't get the direct exact formula for area. Why? Because they are open curves. For circle and ellipse you will have the area of the circle and the area of the ellipse. Why? Because they are simple closed curves. Okay now, so area of the circle is pi r square, whereas the area of the ellipse is pi AB. Understand this? So that means if it is your ellipse is this, so this is equal to A and it is a B. So the area of the ellipse is pi AB. If it is A is equal to B, what happens? You see here, it will become a circle. So if it is A is equal to B, it will become a circle. If it is a semi-minor axis, if it is a major axis and the minor axis are both are equal, then it is a then it will become a circle. Then what is the area of the circle? So in place of A, substitute B, or in place of B, substitute A. Pi into A, pi A square, that is nothing but pi A square, nothing but pi r square, where r is the radius of the circle. Understand this? So very nice. Okay. The next concept is the maximum area of the rectangle that can be inscribed in the ellipse is 2AB, whose sides are root 2A and root 2B. That means if you take an ellipse like this, the maximum, so you can get inscribe different sizes of rectangles. For example, so this is a one rectangle and this is a rectangle, this is a rectangle. So these are all different types of rectangles. These are all different types of rectangles. Okay now, so we have different areas also we will get. Therefore, the maximum area of the rectangle that can be inscribed in S is equal to 0 is 2AB. The area is 2AB. Maximum rectangle is 2AB. Maximum rectangle. Understand? 2AB. So whose side is root 2A and the breadth is root 2B. Length into breadth. Length into breadth. Length is equal to root 2A, breadth is equal to root 2B. Understand? So this is the maximum area of the rectangle that can be inscribed in a ellipse. Okay. I hope that you understand all these 5 points, and let us continue our class. Welcome back. So this is regarding pair of tangents. Okay, here all these concepts at a time you learn so that you remember very well. So here the concept is, let us take an ellipse. So this is an ellipse, x square by a square plus y square by b square is equal to 1. The ellipse is x square by a square plus y square by b square is equal to 1. Whether a greater than b or a less than b, nothing doing. Let us take an external point of P x1 comma y1. Let us take a P x1 comma y1 an external point. From P you can draw two tangents. Let us PA and PB be the two tangents. From this, the first thing what you have to learn is, what is the equation of this pair of lines, pair of tangents, we can say that. The equation of the pair of tangents is given by S1 square is equal to S into S11. So remember this, this is for circle, parabola, ellipse, hyperbola, whatever may be the curve, whatever may be the conic. If you from an external point, you can draw a maximum of two tangents. The equation of the pair of tangents is given as S1 square is equal to S into S11. You know the notations S1 and S11, what are they? Okay now. So the first thing is equation of the pair of tangents. Next comes definitely what will be the angle between them. What will be the angle between them? Then that formula is given as, if theta is the acute angle between the tangents drawn from an external point x1 by 1 to the ellipse S is equal to 0, then tan theta is given by modulus of 2AB root of S11 divided by x1 square plus y1 square minus a square minus b square. So, this is a tan theta formula. Okay. The next concept is, we are saying already, we are saying a pair of tangents. Let the slope of the first tangent is m1 and the slope of the second tangent is m2. Then the relation between m1 and m2 is sum of the slopes, product of the slopes, difference of the slopes. The sum of the slopes is given by the formula 2 times x1 y1 upon x1 square minus a square, and the product of the slopes is given by y1 square minus b square by x1 square minus a square, and the difference of the slopes is given by 2ab times root of s11 by x1 square minus a square. So, this is a difference of slopes. This is a relation between the slopes and the coordinates of the points and major axis, minor axis, length of the major and minor axis. So, these are the relations regarding angle between the pair of tangents, because pair of tangents. So, these all things, all concept, you write it on paper, on book, and so that you remember, always read those concepts, you will remember further. So, in the next class, we will start the problematic part of this ellipse, and until then, I hope that you enjoyed today's class. Until then, all the best.